Hey everybody, today we're on Unit 7, Lesson 5. You can open your workbooks to page 191, and we will be investigating a specific type of distribution called the normal distribution. So for our warm-up, take a look. Each histogram represents a group of 500 healthy people who had their temperature taken. 3 histograms represent examples of data that approximate a normal distribution, and 3 histograms represent non-examples, or data that do not approximate a normal distribution. What do you think the elements are of a normal distribution? So take a look at these examples or look at them in your workbook and pause the video here and you can have a short discussion about what you think makes a normal distribution. Alright, hopefully you had some time to talk about what makes a normal distribution. Let's share some of the elements of a normal distribution. If you take a look, you may recognize this distribution from yesterday. We talked about different types of distribution, and if you notice, all of the examples of a distribution that's normal have this bell-shaped curve that is symmetric, right about the mean. And so those are kind of the big things that you want to get about a normal distribution. Bell-shaped and symmetric about the mean. And so here is a formal definition. Normal distribution is a specific distribution in statistics that is symmetric and bell-shaped. And then this is the other interesting part, is that it has an area of 1 between the x-axis and the curve, and the x-axis is a horizontal asymptote. So there are a lot of things in life that are normally distributed, and I've got another video to kind of show you some examples of that. But distributions that are approximately bell-shaped and symmetric are modeled by a normal distribution. If you want a definition, here's one in gray that they suggest that you write down in your notebook. And you've got a couple of examples of different distributions that are all considered to be normal. They all have that bell shape and they're all symmetric. They may have different mean values, or they may be taller in some cases or shorter in some cases. And we'll look at a couple of examples of that later on. And so we're going to skip over this activity, playing a piano. It'd be a fun thing to do. We could see handspans and see if they're normally distributed in our class. It'd be something kind of interesting to see, but we're going to skip over it for now. And instead we're going to look at this activity, talking about a relative frequency distribution. And so we're talking about manufacturers of butter. They make sticks of butter that weigh 110 grams on average. Manufacturer suspects the machine that forms the sticks of butter may have a problem, and so they weigh each stick of butter the machine produces in an hour. The weights are grouped into intervals of 0.5 grams and are summarized in a frequency table on the next card. And you'll see that same data summarized also in a histogram. And so this information is pretty useful, but might be helpful to know the proportion of sticks of butter in each weight interval rather than the actual number of sticks. And so what we can do is complete the frequency table by taking all of the numbers, which are the frequencies of sticks of butter that are within a certain range. And if we divide this number by the total number of sticks of butter, we will get a decimal number that will represent the relative frequency. So you could pause right now and take out your calculators, and for example, the very first problem we would do is we would take our frequency of 5 and we would divide by a relative, or divide by the total number of sticks of butter, which is 1,171. And if you divide 5 by that, you get approximately 0.004. And so I'll write that in on here, my best mouse marking ability, and so that would get you started. And like I said, you could pause the video here and try to fill in the table. Alright, hopefully you had a chance to fill in the table. Here are answers to all of those, and what you'll notice is that these numbers right here give us rough percentages of each category. And so you could say that this is about 0.4%, 1.5%, 4.4%, 10.1, 14.7, and so on. And then all of these frequencies should add up to 100%. Now I did round, so we might be off by a little bit, but it should be very, very close to 100% when we take into account the rounding. And so a relative frequency histogram is a histogram where we look at the frequency, or the relative frequency, which would be like a percentage. And so we could fill in this y-axis with different percentages that would represent the percent of sticks of butter that would fall into each category. So if you wanted, you could take a second and you could pause the video and you could fill in those percentages on the side of your histogram. And so hopefully you've had some time to fill in the percentages, and we want to move on to our next question, which says the manufacturer believes they should replace the machine if more than 25% of the sticks of butter are more than 1 gram away from the intended value of 110 grams. So it wants you to indicate on the relative frequency histogram the bars that correspond to sticks of butter that are more than 1 gram away from the intended weight. So that could be 1 gram below, or that could be 1 gram above. And then to decide if the machine should be replaced and to explain or show your reasoning. So now would be a great time to pause the video and to make markings on your histogram for the sticks of butter that are more than 1 gram away, and see if you can figure out if the machine should be replaced. Alright, we're back. Hopefully you had a chance to do both of those things, and on this next page we'll take a look at the histogram. And if you notice, what I've done is I've circled or drawn a circle around, or a shape around the bars that represent more than 1 gram away from the ideal weight of 110 grams. So everything below 109 and everything above 111. And what I've done is I've also taken the frequencies, which are the percentages, or the decimal versions of those, and I have overlaid them on top of each bar. And what you'll notice is if we take all of these percentages and we add them all up, we end up with a, well, it says total percent, but it's the decimal number. You could turn that into a percent of 32%, and then that would tell you that there is definitely more than 25% of your sticks of butter that are more than 1 gram away from their intended value. So it seems like this machine should be replaced. And so here are some good discussion questions if you want to take a look at those. And here's a definition of relative frequency histogram, if that's something you'd like to pause the video and write down in your notebooks. And our activity here is talking about the normal curve, and this will be our last activity for the day. And so we'll look at some different curves and make some observations about them and discuss. So these should be in your book. Take a look at the curves that represent normal distributions. You'll notice that there are some similar things and there are some different things. Take a minute to take a look and decide what you notice about them and what you maybe wonder about them, and pause the video and we'll come back in just a second. Alright, we're back. What did you notice about these? Did you notice that these two had different mean values, but they were at the same frequency, 40% at their highest point? They also had a standard deviation of 1, whereas those that had the same height or frequency, 0.2, had a standard deviation of 2, but they were much lower. And so a smaller standard deviation, hopefully you'll notice, corresponds with a higher normal curve, and a bigger standard deviation is going to represent a lower normal curve, and that's because this lower value is because the data values are spread out more. Here we're more concentrated, and so that's a big difference between them. And this one shows a standard deviation that's even smaller and has an even higher peak. So we've kind of discussed all of these questions. Here are some important points that you may want to pause and take a read through. And moving on, our lesson synthesis. When is it appropriate to model data with a normal distribution? Well, it needs to be symmetric data, and it needs to be in a bell shape. How can you create a relative frequency histogram? You'd need to count the frequency of each category and divide the frequency by the total number of outcomes to create a percentage for that. How could it, or why could it be helpful to model data with a normal distribution? Well, one of the big reasons for that is because data that can be represented by a normal distribution, we can know quite a bit about it in terms of the percentage of values that are within a certain distance from the mean, and that will be measured by the standard deviation. The area underneath the normal curve is always going to be 1. And y is a normal curve representing a distribution with a mean of 10 and a standard deviation of 2, taller and skinnier than a normal curve representing a distribution with a mean of 10 and a standard deviation of 3. It's because smaller standard deviation means that your data is less spread out, so there's more that will more values that will be closer together, creating a higher frequency, and therefore the normal curve will be higher. Whereas when you have a larger standard deviation, it's more spread out, and so the frequencies will be lower. And hopefully that gets you by for 7.5. There's one more video I'd love for you to watch. It talks about normal distributions, and then we've got some work time for some practice problems. Have a great day.